Thank you for having me, guys, here. This is Hassan, and I have worked with multiple SaaS products in the past, and I've been in this industry for more than 8 years. I'm a director in Liberty, and I am also a security researcher as well, and I've loved to perform security research. So this research is totally based on educational purposes, and nothing has been done for the malicious intent. So this talk is going to be about supply chain security and the dependencies and the dependence it have. So before jumping into it, we first need to understand what is an open source. So basically, an open source is a piece of code or component that can actually be used by other users as well, right? You create something and then you publish it, and anyone can clone it and fork it and maybe work through it. So this is how supply chain works, and this is how open source community works as well. And when we talk about open source, then we are actually aware of that it could have multiple vulnerabilities, right? It would have a lot of attack surface and exposure because the code is already published somewhere, right? So it could have unpatched vulnerabilities, it could have unmanaged packages, it could have malicious packages or code which someone has actually attributed or put something in the code, or maybe the secrets. And this is the main topic that we are going to discuss today, the secrets, right? So how does a software supply chain works? So basically what happens when a developer codes something, okay, it's either a one component or it's maybe a multiple components. He builds the code, he sources it, he packages it maybe into a package file or something like this, and then he just pushes that code publicly. So this is how a software supply chain works. But in real world scenario, the software supply chain is not only depends on one component, it depends on multiple components, right? It could have dependencies, it could have a lot of third-party modules, it could have a lot of third-party code as well. Because when we develop something, even in the software development industry, we have seen in the front end and in the back end, we're not only relying on the your own code, we're also relying on third-party codes. We import modules, we import dependencies to get some extended functionality from these modules. This is how software supply chain works. And when we look into the open source community, we see the JavaScript is most widely used, right? And then we have HTML, Python, PHP, and other languages as well. So in this research, we are going to focus the core component is going to be JS, and then we also be covering the secret scanning part for the WordPress plugins and the Ruby gems as well, right? So here's a sample package. You can see the Express package, and this package have currently 70,000 plus dependents and 31 dependencies. So this means if this package is compromised, it's going to affect many other packages, right? This is same scenario. This was the same attack that happened last year, and it really affect millions of packages, right? At that time, there was no defensible approach, no defensible strategy outlined in the market. So we did this research. We tried to identify how many packages are vulnerable there. We extracted all of the packages at that time that were available on npm.js. It was nearly 2.3 million npm packages. And after looking into those packages, we came to know that near 3,000 to 4,000 packages were vulnerable. And I recently mentioned whenever a single package or piece of code is vulnerable in a supply chain, it really does not affect only that component. It affects multiple other components. So here you can see these near to 3,000 packages are actually dependent on 93,000 packages. And their dependent repositories are more than 200K, right? So this means there are a lot of people who are actually forking it or maybe contributing these packages as well. And we have the numbers of forks as well. So the impact was huge. After doing this research, we analyzed, okay, we did deeper into the account takeover strategies. We tried to find those vulnerabilities, right? But what about secrets, right? So secrets are a piece of information that everyone uses in our code. As a software developer, when you are developing something, you create an env file, right? Most of the time we create an env file, and in env file we define something like Firebase token, AWS key, Stripe API key and stuff like this, right? But have we ever thought about leaking those secrets somewhere, right? So this is going to be our main topic of this research today. So what happens when these secrets are leaked? So this happens, the largest breach happened of Binance last year in 2022. And then we have more incidents. Incident in Microsoft. Then we have another incident in Toyota where the leakage of customer emails was happened. And this happened just because of the secrets being exposed. And most of us have used Slack in the past, right? In our professional environment for the communication purposes, we have used Slack. They have been also breached using a secret exposure. And through this exposure, an attacker was able to literally compromise their users' integrity, right? So this is the impact of the leakage of the secret. More incidents. SourceGraph, they also had a breach in 2023, and this happened just because of the secret. So when we are talking about the secret leakage, we are not only talking about a single source, right? We are not only talking about .env files, right? As these major incidents, you can see these could have happened through the multiple sources. For example, an AWS code could be leaked in a GitHub repository, right? Most of us who are developers here, we sometimes use products like CodePen, Pastebin to share code with the colleagues, right? So these are the scenarios that helps an attacker to look into these sources and extract the secrets that are belonging to one customer. And when we talk about the secret leakage, it just not only affects the single organization, right? There was a breach happen in Cloud Climate as well. And that token was breached through the GitHub repository, and the breach and the attack was able to compromise its customer as well. So we can see the breach happens in one organization, then affects the other organization, right? So this is how software supply chain works. If one thing gets affected, other stuff that are actually connected with it, they're gonna be affected as well. Other attacks we have seen in the past, these are the attacks happened. So one thing I want to mention that I just previously explained, I just want to explain one thing more here. As I mentioned, whenever a supply chain attack happens, it does not affect a single component of the chain. It affects all of the connected components. So in this attack scenario, there was a malicious NPM package. Actually, the package was not malicious, right? The package was using an S3 bucket. And after some time, the developers maybe thought, okay, we are no longer, using this S3 bucket. We're no longer using this bucket, and they just abandoned the bucket, right? Someone actually claimed that bucket. And now the package who was using some JS files were actually compromised because someone claimed the bucket, and now they have posted malicious stuff into the bucket as well. So anyone could have for example, if someone is using that package, he is now cloning the malicious files in his own PC, right? So this is how software supply chain works. So one component was vulnerable, and now it's affecting the other components. So this is how the software supply chain actually works. These are all the attacks happens in the past. There's not a single attack. There are multiple attacks. You can see even the most funniest thing I can show you is the Bugcrowd and HackerOne. If you go to the Bugcrowd or HackerOne, you can see their previous reports. You'll came to know like there are many researchers who reported these vulnerabilities. So what people do, what researchers do, they just look for the GitHub, Bitbucket, and GitLabs and such sources for the exposures, right? You can go there, you can look for the exposed secrets or maybe token or API key, something like this. But when some things happen like this, a secret leakage, it's going to be affect the other parts of the supply chain as well. And these are all the examples you can see in this slide, right? So another good question that you guys are currently having in your mind, like how did we do this research? Like even if we look into the number of NPM packages, these are actually more than 2.3 million packages. If we look into the WordPress plugins, there are more than 6,000 plugins. So how did we actually do this research? How did we do this research at scale? So the first part of this research is to collect all of the source code of all of the packages, right? And that we did this. We collected all of the Ruby gems. We collected all of the NPM packages. We collected all of the WordPress plugins. And then we used highly available, they have a really good resources RAM on the VPSs. And then we use these VPSs to perform the research, right? So the first part is to collect all the source code. The second part was to perform the extraction. And when we talk about the extraction process is quite hectic process, because not only a single package is like 1 MB, 2 MB, 5 MB. There are some packages, there are some open source solutions that are actually like 5 GB, like 6 GB. So it was the total data was literally in TBs. And we have to extract and we have to perform the scanning. So we did this part. We used 33 signatures. These signatures are, you can say, the rejects. They are able to capture tokens in your code base. For example, a Telegram token, AWS token, Google token, something like this, right? So yeah, let's jump into the results of this research in the WordPress plugins first. Why WordPress plugins? Because 44% of the internet have been using WordPress, right? The WordPress CMS is mostly used on the internet. So in the first part of this research, we first collected around 60,000 WordPress plugins, which were active plugins. None of them was inactive. And through these plugins, we were able to identify almost 3,500 plus exposures, right? And we used 33 signatures. By the numbers, it might look like, oh, that's a very small number, right? But as I have explained before, a single exposure is not only affecting one customer or one website, or one user. It could affect many other people. So the total installation of those plugins were around 35 million. So just imagine if there is a malware or maybe something like this in one WordPress plugin, it could actually affect many other plugins. And if we look, the total number is 35 million. And the most common and most funniest file that I found while performing the validations was README, right? So whenever we are creating some security tools, developing some code, we always have a README file. And it was really astonishing, and to be honest, it was really funny to see like people are actually exposing their AWS keys inside README files. And those keys were actually valid. And it was hilarious, right? So, and when I Googled this scenario, because I wasn't able to believe in myself, okay, how could someone just leak the credentials on the README file? And then I Googled and I then researched and I just saw that this kind of leakage happened in the past. Like, it's a Microsoft AI researcher who accidentally exposes 38 terabytes of confidential data. How? Through the README. So this actually emphasizes the security awareness of the developers, of the security researchers, or anyone who is, involving with the development sector and are actually using some secrets or information like this in their code base. What else? We were able to identify 41 AWS live keys, which were actually working keys, and you can see the redacted screenshot because we have to redact that for the customer's satisfaction. And the active installation of the total of these plugins was 6 million. Private key exposure. Private key, as you know, these kind of keys are used for the SSL encryption. Some are used for the SSH itself. And it's really funny to see like people were just simply exposing these in the PEM files. And the exposure, you can see that total installation was 12 million. The number is getting huge now. Basic authorization credentials. Whenever we work with the products, we use MongoDB, we use PostgreSQL, we use some SQL stuff like this. And the funniest thing that people putting their username and passwords in the code, and it was So interesting. As you can see, credentials everywhere, and we were very shocked to see like how could this even happen. And you can see the total number is 166. I know the number is very less, but these are actually active credentials. We tried the few and it worked. And then we validated those and we removed the false positive, and then we came up with this number. And these could be actual 166 companies. Maybe a SaaS company, maybe it depends to, some finance sector or something like this. Other exposures, Google API keys. As you know, these keys are used for multiple purposes, for YouTube, for tracking and other stuff, right? And stuff can happen with Google API keys, right? The deep of their usage, some stuff like this. GitHub app and GitHub personal token, and this was literally 12 tokens, but these 12 guys, they were not doing really great, right? It's not really a good idea to expose your GitHub, as someone can make changes, they can do commits. You guys know what stuff can happen if your GitHub token is exposed. Slack exposure, this was another blunder that I have seen, and I was really shocked to see that how could someone just leave their Slack token out there. You can make an API calls, you can post something to a specific channel. Of course, you have to figure out what channel this could be used and other stuff, but this is very interesting thing to see. Firebase database, it does not only leaks the Firebase database, it also leaks the API key, the storage bucket, measurement ID, and stuff like this, right? And yes, the famous Marvels meme that I really love. I see secrets everywhere. And that's not just the end of the secret scanning. There were secrets of Code Climate, MailChimp API key, Telegram bot, Twitter, Zapier, and there were many others that I did not even mention in the slides because I don't want to bore you, but there were many other secrets. So just to summarize, this is the meme for the pending secrets. And yes, for you guys, we have a tool which is publicly available and does all of this scanning. You can actually scan this QR code and it will redirect you to the tool. So what tool does, you first clone the tool and you install the dependency. Then you provide the argument, npm.js, just provide a single package, maybe express or something like this. If you don't get any output, it means the package does not have any vulnerabilities or leakage, something like this. But when you try with multiple packages, you can find if it shows exposure. You can also try out with the file having a multiple packages. Just put random 100 packages, npm packages, and you will be able to get some results from it. You can also provide your own source code. You can, if you work for a company, if you have a personal project, you can zip it and provide a zip file to this tool, and the tool will be able to identify the leak secrets in it, right? So this part was just a very small chunk of what we have seen. It was only in WordPress plugin, and the major chunk, the chunk which is the most secrets are npm.js, and Danish will be explaining you what we found there and how we did it. Danish, over to you.
So, hello everyone. Can you guys hear me? Okay. So, yeah, I'm Danish, and I have, spoken at Black Hat twice, and I've been doing research and cybersecurity consultancy for last 8-9 years. And yeah, it's a little bit about me. If anyone wants to connect with me, they can scan the LinkedIn, and we can connect over there. So yeah, as Hassan talked majorly on the secrets in a WordPress ecosystem, the WordPress plugins, right? But the WordPress plugins are in a lower range, or there were around 60,000 plugins when we did the research. But NPM ecosystem is very large, right? So the whole number of the NPM packages or the JS JavaScript packages were 2.4 million, more than 2.4 million packages out there. So what we did, we actually, you could say, extracted all of these packages, and then we ran the exact same scanning of these packages for the for the lookup of different secrets, the similar ones and the different ones as well. And we are now going to talk on the results and analytics of what we found and what were the common files out there. Yeah. So we were able to identify our signatures actually got around 100k plus 130k plus secrets, but actually we removed the false positives as well, because sometimes people do tend to use sample private keys or the sample AWS keys and stuff like that. So we actually removed those sample keys, testing keys, and false positive results, and obviously did the validation of some of the keys as well, and then we got the actual secrets from the NPM that we had, and that was around 93,000 plus at the time of the research that we did. So the most common files in the NPM were these ones, and obviously other files, and some interesting files were obviously the .env, and again readme was the most common file within the NPM as well, causing the leakages, right? Talking about AWS, so we got around 6,000 plus AWS keys, access keys, obviously SNS tokens and other keys of AWS as well. And the most common file for the leakage in npm.js for the AWS keys was index.js in the packages. It's an example of a code snippet that we found in one of the packages where the secret key of the AWS was being leaked. You could just imagine the impact of S3 bucket takeover, read and write and whatnot, right? So moving forward, these were the number of GitHub tokens, whether personal, refresh and auth tokens. So we covered all of these. Obviously some tokens are meant to be expired in a timely manner, but we try to cover those as well. Personal one is mostly the most important one in this part. So talking about the signatures that Hassan recently mentioned as well, you can see some of the identifier in the secrets. For example, the GitHub personal token starts with GHP and underscore, and every different token have their own identifiers. For example, GHR for the refresh tokens, and these are the actual real life code snippets from the NPM packages where we found the secrets. So again, GitHub could be a disaster if got into the bad hands, right? Again, Slack 187 Slack API keys in the NPM JS and webhooks were around 300, and Slack.js was the most common file. Some of the identifier and code snippets from the NPM JS. This is one of the largest occurrence of the secrets exposure, the basic authorization credentials. It included various different types, whether we talk about MongoDB credentials or even the admin panel passwords and stuff like that in different packages for their admin portals, for their MongoDB and whatnot, right? And again, the most common file for the basic authorization credentials are readme, index, and package.json. Weirdly, some of the code snippets from the packages itself for the leakage, right? Again, Zendesk is there, a very small number, but again, it could be, we could assume that Zendesk, what could be done on Zendesk, what customers' data could be leaked, and then, stuff like that. You could see the token, email, Zendesk URLs to access that data, right? Zapier were there. The most common file was zapier.yaml, and this is one of the code snippet that we got from NPM. Twitter secrets were there. The most common file for the Twitter secrets were .env. The leakages that I'm talking about were mostly in the JS packages because WordPress was already covered by Hassan. And then Telegram as well, some of the numbers, some of the common files. Stripe is a dangerous one. You might assume that there are two different type of Stripe keys, obviously public and private one. So obviously we removed the public ones as a false positive, and private keys were fetched, and there are difference between private and public key. Public key starts with the PK underscore live or something. Yeah, so the Stripe leakage is one of the dangerous ones as well. It could be a financial loss for the company. It's not that NPM packages or the JS packages are always developed by the individual developers or the open source contributors. Most of the companies do that as well, obviously, right? So these Stripe API keys would be of the companies, of the SaaS products that were leaking these keys, and obviously these were reported to those companies as a responsible disclosure and open source contribution. MailChimp, again, SendGrid, Google API keys, one of the largest occurrence. There were occurrence of Google Map API keys as well, but that could be a DDoS problem and monetary loss as well, right? Then GitLab, personal access tokens, code snippet from one of the NPM package. Firebase was in a huge number, again with the README as the most commonly leaky file, I would say. Yes, this is the code of the actual NPM package. Code climate tokens were there, around 518. This is a sample of a code snippet. Private key, it's one of the highest number of occurrences in the NPM JS as well. Around 43,000 plus private keys were being exposed in the NPM ecosystem, and the most common file was server.key. In the case of WordPress, it was private.key, and in the case of NPM, it was server.key. And this is an example of a private key being leaked in the NPM JS packages, right? Yeah, some little ones. These were the, I think, lowest occurrences of the tokens that we found. Some Discord ones, Heroku, and stuff like that. Yeah, so again, we didn't stop at NPM. We also scanned Ruby gems as well. We extracted, downloaded mostly all of the publicly available Ruby gems, and then we scanned those for the same signatures, 33 different types. We were able to identify 16,000 plus secrets in that. Some of the common ones are I wouldn't like to bore you with the same repetition again, so I would put it in the same slide. Yeah, these are some of the occurrences in the Ruby gems. Next, we are planning and we are doing some work on the PHP and Python packages as well to look for the secrets. It's addictive in a way. So what's the significance of leaking secrets? So according to the IBM cost of a breach, the most costly breaches are done because of the compromised or the stolen credentials, and secrets are one of those credentials. So yeah, this is the significance of leaking secrets and protecting against these type of things. So what should be done before the secret is leaked and after the secret is leaked, right? So for example, should we, if a secret is leaking in a GitHub repository, for example, should you just delete the file of the GitHub to remove the secret from the public eyes? But that is not preferable most of the times, because it could be in the history of comments and whatnot, and obviously if once the secret is out, it should be considered stolen and it should be revoked. You should review your access logs, whether it is AWS or whatnot, and then assess if that file or the repository is important to be public, and if so, you should consider removing secrets. This is a NIST guideline on the secrets as well, for the compliance, compliance geeks, I would say. GitHub does have a good secret scanning functionality. You could also utilize that in a way. You could use good secret management platforms depending on your setup and environment. You could use Azure Keyboard, you could use AWS SM Perimeter to actually, deploy those secrets in a safer manner, and obviously have some automation within your CI/CD pipeline to look for these secrets when you are developing something, and don't commit the secrets. So actually we are also, working, it's mostly finalized. We are going to release it soon. A small, effort towards mitigation of these secrets. We are working on the platform in which you could scan the packages, scan your code files, your zip folder to look for the secrets, in a similar way that we have done. It's a demo of our actual product, which would be public soon, and you could look at it. For example, obviously we have redacted the names because of ethical reasons, and this is sample redacted package that we scan, and you would see results in a bit, depending on the size of a package or the size of file that you are scanning for the secrets. For example, you would look at these basic other credentials. We have redacted the stuff. MongoDB was there, and stuff of this sort. So this would be public soon on our domain. So if you want to join the waitlist for this product, you can scan the QR code or preferably use the URL if you have a better you can join the waitlist, and once the product is announced, we would be sending you invite an early user. Obviously, initially, on a beta version of our product that you could use. Other than that, if you want to, if anyone more is interested in learning on how these type of mass scannings are being done, millions of packages and whatnot, we have a workshop at HITB Abu Dhabi in November. You can look into it, Art of Mass Scanning, and another one. It's mostly on the software supply chain from offense to defense. It includes not only the secrets, obviously, it includes different scenarios, vulnerabilities, and whatnot on the supply chain part of things in Abu Dhabi, November, HITB. So if you have any questions, please ask, and we would be happy to answer that.
Do we have any questions from the audiences? All right then. Thank you very much for this insightful talk. Please give them a big round of applause.